now we're going to try and find the derivative of the inverse tan of x. Sometimes it's written as arctan of x. So these two are essentially the same. So our aim is to find out the derivative of this and this here. But before we try and find the derivative of this, let's try and understand this function first. What does inverse tan look like? What does the graph of inverse tan look like? So start out by drawing your graph of tan of x. So your tan of x looks like this. Okay, so your tan of x looks like this. So inverse tan of x will be a reflection of this here. So the inverse function will always be a reflection along the y equals x line here. So it will always be a reflection along this line here. So when you come, so at the moment the red line is y equals tan of x. So for us to understand y equals inverse tan of x, we've got to reflect it. So looking at this strand here, this one strand here, when you reflect it, it will look like this. Hang on. So you've got an asymptote along here at pi over 2. So that means when you reflect it, you're going to have an asymptote. Well, if you look at this strand here, if you reflect it, it will look something like this. Hang on, let me think. It will look something like this. Okay, oops. It will look something like this. And then here, hang on. Yeah, so along here it will have another asymptote at negative pi over 2. So it will look something like this. Okay, so this one strand here so this strand here will get reflected and it will look like this. But then don't forget you also got this strand here. So when you reflect it, you're going to have another line another line somewhere up here as well. Okay. Well, anyway, so start out with this. Okay, start out with your tan of x here. And then you reflect it. Now, hang on. Me reflecting this, hang on, let me just, so now we're going to reflect this. So, well, reflecting it is essentially the same as me, flipping it. Well, I am in effect going to reflect it along the y equals x line. But I'm going to do it by flipping it and then rotating it. It will be the same thing. Hang on. So flip it vertically, and then, hang on, and then rotate it anti-clockwise by 90. That's the same thing as reflecting it along the y equals x. So hang on. So this here, it is in effect a reflection. You got to take my word for it. You reflecting, hang on. You reflecting, hang on. So let's say you've got a graph here. You reflecting it. Let's say you've got this point here. You reflecting along the y equals x line is essentially the same as you flipping it flipping it vertically. So that would take it down here, and then rotating it 90 degrees anti-clockwise. So it would take you to here. It's essentially the same. I know it's kind of weird, but it is the same. Suppose you've got a point here, and you want to reflect it. If you reflect it, this will be this short distance up. It will get this point here will move to here. Now, reflecting it along this line here is the same as you flipping it vertically, so that would move down here, and then rotating it 90 degrees anti-clockwise, so that would take it to here. Okay, so suppose you have a point down here. Let's say here. Okay, so if you reflect it along this line here, it should get to here. So now, yeah, so if you reflect it, this point here will move over to here. But then it's the same thing as me flipping it vertically. That would take it to here, and then rotating it 90 degrees. That would take it to here. So it's essentially the same thing. Okay, so when you have your your graph of tan of x, and then and then you reflect it along the diagonal line, it will look like this. and by right you will have lots of strands here. You've got another one up here, okay. You've got another one up here, and then you've got another one up here, and so on here. So you're going to have lots of strands here, okay. And even in the negative realm, you're going to have some more strands here. But the thing is, remember, a function is when you draw a vertical line and then you only have one. You see, at the moment, this graph here, when we reflect it along the diagonal line, this is not a function because if you draw a vertical line here, you have this point. This here is not a function. So in order for us to turn our inverse tan, so when you reflect along the y equals x line, you get lots of lines like these here. But in order for us to create a function, we're going to discard all these lines here. We're just going to get one strand. Yeah, so by us discarding all the other strands and just keeping one strand here, we will now have ourselves a function. So this here is a function, and don't forget this is an asymptote here. So you've got a horizontal asymptote here. Okay, so yeah, so starting out with our tan graph, it will look like this. But when you reflect it along the diagonal line, it will then give you, by right, it should look like this. Okay, but then we want to cast this graph into a function. So we need to get rid of all these strands here and just keep one, because by just keeping one strand, we now have a function. So we've just created a function. So your y equals inverse tan of x here will look like this. Okay, so this is your yeah. So that's what your graph looks like. Okay, so if you get a graph plotter and plot y equals inverse tan of x, or y. So sometimes it's hard to do this on a calculator. Sometimes you have to do this arctan of x. Okay, so your graph now looks like this. Okay, yeah. So your graph now looks like this. So arctan of x looks like this. Okay.